All right, so today we're going to walk through how functions work today. And I'm going to be actually just backing up. In this whole presentation, I'm going to kind of cover this at a high level. I wasn't sure exactly what sections if people want to take a deep dive in. So if you have questions, please ask. There aren't too many participants, so feel free to just jump in and ask a question voice or use the chat. So I'm going to go through and do a quick high level of how functions are already working, and then kind of walk through what we're planning on doing and what we're working on right now to improve the functions in Presto. So today, you can register functions via the plugin interface in the SPI. If you look at the plugin interface, it has a method called getFunctions, which returns a set of classes. So what we do is we walk through the classes and we search for annotations. And there are a bunch of annotations like, @scalar function and @operator and things like that that will define what are the scalar functions, the operators, aggregations, window functions. And so we basically pull together all those functions, and then we add all those functions to the single global shared namespace for functions. So if you happen to create a function that collides with someone else, I'm pretty sure you get an error and the plugin fails to load. And actually your server probably fails to start at that point. And the other thing is that the functions are automatically loaded when you add a plugin to the system. So, which is almost always all the plugins are added at startup. So this doesn't work like connectors do, where you would create a catalog file and say, here's the catalogs I want added. You simply add a plugin and it adds all the functions.
By adding the plugin means the jar files of the plugin are present in the deployment directory.
Correct. Yeah. So this is what an example function. I just pulled this out of the code base. This is a function that is named UUID, and it's returning a random UUID. And as you can see, there's a description, which is printed when you show functions. There's an annotation that says this is a scalar function. Value is the name. Actually, I don't know why we're saying that, because that's the default name, is to just lowercase everything.
That's because we have the deterministic flag there. You have to specify it.
Yeah. And this is not a deterministic function because it's random, which is one of the options for it. And then you have to declare all the types. In this case, this thing's returning a varchar. If you have parameters, they'd all be listed there with types. And if you want to see how to write these, I just suggest searching through the code. There's tons of functions in there. All right. So there are a number of problems with the existing system. So as I mentioned before, we have a single namespace, and you run out of good names pretty quick. And there's a thing that basically we force all the functions to be registered up front, which means you need to know what all the functions you're going to want. And if later you want to add new functions, you pretty much have to restart your server, is what people do. And you can't update them clearly. This may not seem obvious, but one of the big drawbacks is that you can only use annotated classes, which means if you have an existing library of functions, you basically have to go through and create all these boilerplate classes for it. There's no programmatic interface to present functions to the system. And another really big downside that you can kind of see in the previous example is there's no opportunity to pass really any configuration to functions. So there's times when you may want to have a configuration flag in the system to control the behavior of functions, or even what functions are registered or things like that. It's just a static block of functions that are always registered. So now we're going to start to get into what we're doing about it. So the first step is clearly introducing namespaces. And the SQL specification has had namespaces for ages. The functions are attached to schemas. So as everyone remembers from the Presto setup, is that we have a catalog schema. We have a 3-dotted system. So they're attached with a full 3-dotted, with a 3-part name. So you can absolutely refer to them as their catalog schema function name. That of course would get annoying. So there's a search path, just like you would have in any Unix system. And you can say, like, I want to search these schemas in the following order. And the system will go through and resolve functions against the schemas in order, looking for one that matches a name if it's not fully qualified. And there's a set path. There's a current path function, like current user, so you can look at what's going on.
So functions are entities. They're objects in SQL, just like tables and views, and I mean they have the same. You should be, like, according to the spec, you should be able to create them, drop them, etc. Is in the same way you would manipulate a table or a role or a user or something like that.
You can also set permissions on them. So there's an execute permission and some other things like that. So we're working on an implementation of that. And then as part of that implementation, we're going to extend down to the connectors through the connectors already have an API to manage their catalog. So they have this metadata interface to like resolve tables and things like that. So we'll be extending that so that there'll be some sort of resolve function. So I'm showing some example function signatures here. This is actually not at all what they're going to look like. This is just kind of illustrative to describe to you guys what will happen. So under the covers, when the system runs into a function, it's going to turn around and go through the search path and say, hey, do you have a function with this name and these types? And at that point, you'll be able to return, we'll basically build a handle out of the function if it resolves, so that later on a worker, we can go back and fetch an implementation for that function and stitch it into the execution framework. So it should feel similar to anyone who's written a connector before to deal with things like give me a handle to a table and then give me something that can give me the data for that table. So it's a similar API system. This, of course, will be part of the existing transaction framework in Presto. So you'll be able to have access to the transactions. So you'll be able to create functions that you'll be able to make sure that everyone sees the same version in case there's like an update in the middle and things like that. So that's the previous section is basically how do we get functions participating in real-time resolution. All right. So the next section is how do we make it easier for end users involved in the system to define functions, and how also do we make it easier for connector writers and admins to provide functions. So as I mentioned before, currently we only support annotated Java classes. So we get by that, but we're still very much in you write your functions in the Java language or in a language that converts to the JVM. With the next section, what we're talking about is introducing SQL Defined Functions. So this is another thing that the specification has had for a really long time. There's commands like create function and drop function. This, a good place to look is actually MySQL. So they have implementations of create function and drop function that use the SQL procedural programming, the procedure language that they have built into SQL. It's part of the specification. It looks like BASIC and has basic constructs. But with this create function and drop function, you can specify, I want to create a function, here's the body of the function or a single expression for that function. The language also, the specification also allows additional, the specification also, sorry. Yeah.
Let me move the window.
Yeah. Sorry. The specification also allows for you to have multiple languages. So you can actually, when you declare your function, you can say what language you would like. What we're going to do is we're going to add in a language interface into the system. And again, this is very hand wavy. These are clearly not going to be the exact interfaces we're going to see. But the idea is that what we're going to start with is we're going to create a simple implementation of the SQL procedure language, and we have a prototype for that already. And we're going to use that as a way of introducing some sort of system that allows people to plug in really any language they may want. So if you want to implement like JavaScript or Ruby or something that you can clearly compile to run in a JVM, and you want to expose that to users, that should be possible. The challenge is going to be how you actually map from the SQL type system to the language type system. So how do I map a decimal type into JavaScript if I want to use JavaScript? So there'll be challenges around that, but it will be possible for those who want to go down that path. So what we'll end up having is something that's, along the lines of, we basically think of the connector as being responsible for storing the definitions of functions. So you can think of this like we do with views today. We basically are handing off to the connector like, hey, we want you to store this view under this name. This will be the same thing. We want you to create a function with a certain language and a definition object of some kind. And later, when we go back to get the implementation, we'll need to get that definition back so we can then hand it off to another plugin that people would provide that would convert that definition into something executable, like a Java method handler or something like that. It's kind of the direction we're thinking. It'll become more concrete as we try and integrate the SQL language prototype into the main system. I think I missed a point. Oh, yeah. One of the things we are talking about is thinking about is this second point is more than just having create and drop function, which would modify a global catalog for everyone, is to support possibly a query local function. So think of having a with function, like a with expression inside of an existing query where you could, currently with expressions are only for defining like local views. So a table. This would allow you to find a function that's only local that query. So it's something we're thinking about. We're not exactly sure what the demand looks like for.
Yeah, there's nothing in the spec around this. There are some databases that implement something similar. So we need to do a survey of what they do and what's reasonable and what might be feasible, or what the spec might end up doing if they ever support something like this.
So one of the dangers with things like that is people could define functions that are extremely computationally intensive. That's not a huge concern because you can do that anyway with tables. Like you can just cross join some tables together and do a really expensive computation. So what we have so far basically gets us so connectors can participate dynamically live inside of function resolution, and it allows the next part will allow the SQL Defined Functions allows end users and sysadmins an easier way of defining functions other than sitting down and writing Java code. So the next class of functions there are a bunch of functions that you really can't or don't really want to run in the same process as your Presto system. So this might be like where you're getting code from other departments inside of your system, and you're not sure if their code, you don't trust their code to have access to the system that has, direct access to the storage system. Like, you're just not comfortable in running that inside of your secure Presto environment. It could be code where you don't understand the reliability of it. It could be really resource intensive code. Or another very common example is like you have existing functionality in remote systems, and getting that to embed inside of Presto just isn't really worth the work. So the idea with remote functions is that instead of executing locally, we send the function arguments to a remote system and they send us the answer back. And that way, the code's not running inside your environment and you're not sucking resources out of your Presto systems. The key to this is we have to add a batch calling convention. Doing remote calls, even if they were on the same machine, doing them one at a time across the memory boundaries where you have to take the arguments and serialize them and then take the results and deserialize them, it would be too slow to do one at a time. So what we're talking about is adding a batch invocation interface. So the interface will look something like, I pass in a page of arguments. And so a page in Presto is, it's a bunch of columns of data, and each column has the same length. So if you think about that, you row orient to that, then each row would be a single invocation of the function. And then the result would be a block that is the same number of same number of rows as the input. And so a block is a single column. So we would basically take a whole page worth of invocations, send it to the remote system, and get the answer back. The difficulty in implementing this is that we have to separate the remote function invocation from what happens today, because what we do at Presto today is we take complex expressions. So if you have like f of g of h, so nested calls, we take that whole expression and we compile it into a single block of byte code that invokes all of those in order in a single. It basically takes the whole thing and generates a new function that does exactly what the nested ones do. And we do that because that basically allows the Java virtual machine to inline the implementations of these functions, which makes them super fast. So the problem is that if we're going to have some function in the middle of a complex expression be a remote function, what we need to do is take all of its arguments, run the functions for its arguments, collect the output into a page set of arguments, and then send that off and get it back, and then start the computation basically again. So it's a pretty complex change to the existing system. We have to split the expressions apart and understand there's calling conventions. So it'll be some work to get this going. So.
Yeah, I just have a bunch of ideas. So this actually looks exactly like a table function. It's a function that takes an input table and produces a table as output, which is, it kind of ties into what we're gonna, the next thing we're gonna talk. But we might be able to model that as any function that's a table function could be invoked in the context of a scalar by running it through this mechanism. So it's effectively you could think of I know, projection, a filter, etc. as table functions. It's any operator in SQL is a table function. They process an input table, it produces an output table. So I think there might be things we can leverage for that.
Yeah.
Have you guys thought at all about the latency and doing, I guess, asynchronous calling of remote services? So you could like pipeline, some requests are in flight while others are being issued?
Yes. So, I think we can do some here. I'm not sure we can do huge amounts because of the way the operator system works. So right now the operators we can basically keep feeding input into the system. The only constraint would be if we had to hold on to all of the input arguments, but I'm pretty sure we can just drop them right away. So we could go and basically every time we get an input page from the source of this, fire it off to the remote system and then get the response out. The operators would probably have to maintain ordering, so we'd have to wait for them to come back in the right order, which might require a bunch of buffering if you're not careful.
Yeah, so surely you will need to tag the request, either reorder or match the request to data. You cannot drop all the arguments. You can drop anything you don't need to pass further, but you need to retain the data that you are to pass further. But if you, for example, want to have 10 calls running asynchronously at the same time, it's not a small number, especially per thread. Then you need to keep 10 pages in memory, so it's not a huge deal.
Yeah. So what Piotr is talking about is that you're going to have pass-through arguments. So you're going to filter some of your columns through this function, but then some of the columns you're going to pass through raw because they're not being passed through the function. And so you'd have to buffer all of that up. Yeah, that's a really good point.
You have to hold on to it anyway for retries.
Oh, yes, obviously. Yeah. So you have some memory constraints on that sort of thing. Normally we suck up this sort of latency by just running a lot of stuff in parallel, which also takes a bunch of memory. So
yeah, I have a question, actually a bunch. So about the isolating complex expressions. So this is obviously required for remote functions, but one could think that isolating expressions might be a good idea in general. So then you said about inlining when function calls are combined, and this is a good point. However, another thought would be that if I just run the same function on a sequence of arguments and then subsequently run a second function on a sequence of arguments of data rows, I could, like, for example, arithmetics, I could do some, for arithmetics, it's obvious that I could gain vectorization of computations on the CPU. Question is whether I can get something like that, some benefit like that for function calls.
Yeah, so there's this, what's that paper from Google where they actually dig into the cost of, so they compare the Tenzing paper. So they compare the cost of compiling down complex expressions versus doing them in column-wise and then combining pairs back together. And they found that for simple things like when you're dealing with arithmetics, that it's actually the CPUs are better when you actually just feed them all the complex code at once. But clearly, if you run into something like a complex regular expression that's like repeated multiple times in an expression, you're going to want to run that once because it's so computationally expensive that you basically want to reuse the output of you want to share the that invocation. So I think that there's a need to be able to deal with expressions in either a way where you can peel out like subtrees of the expression and execute that, and then use that as an input to the next phase of the execution of the next phase of the expression. And then there's clearly the case for what we're doing right now, where you just combine it all together and run it. And then, you know, you need an optimizer to figure out which one you want to do.
Well, I mean, at the bottom, there's a trade-off. So if you do the inline, like you do one loop with the entire expression inlined, you're not materializing any intermediate results other than inside the CPU in registers and so on. If you split it up and you're materializing into memory buffers, the question is the CPU smart enough to figure out that those are going to be shared, so they can go in, I know, into CPU cache and that kind of stuff. So it really depends, and I don't think there's a silver bullet for this. You can go one way or the other in every case and be a definite win. So, well,
So
we can
for
do.
example, if I do multiplication and addition later, if I do this in 2 steps, I will need to flash back the memory, the data back to main memory and read it again into CPU.
Well, especially in the case of multiplication and division, those operations are basically free with the memory loads, and you'd basically be doubling the memory load. So we actually wrote that exact example when we first started Presto, because we were working off of the C-store paper, which argued that this is the way you should run executions, and we benchmarked different ways, and it was pretty clear for the vast majority, for like all the simple expressions, that compiling them into one case just was like orders of magnitude faster.
And for that, the expression we use for like a regular expression, we can do that today if the underlying data is dictionary encoded, because we can process that on the dictionary.
Yes. So I think this actually becomes a lot easier with the work processor stuff that Carol is doing, because that allows us to be much freer in our combination of layers of projects without having a lot of extra costs, where we do today of going through the full operator interface.
Okay, another question. Did you, when thinking about remote function, did you think what the data representation in the wire should be?
Our plan for remote functions is that it's going to be a calling convention where we're going to pass to the function a full page and get back a block, and then different plugins will implement remote functions the way they want to do it. So we'll, add a thrift version under the thrift plugin that'll use thrift, and then other systems would use whatever is natural to them.
Yeah, I think the answer is Presto won't intrinsically know about remote functions. It's just a different way of invoking a function that allows us to process in batches, and it's up to the connector to decide whether it does it in process, out of process, remote to a different machine, different protocols, or whatever.
Yeah.
Kind of, because as you said, remote function requires some special handling in laying out the code. So you need to isolate it. You need some dedicated operator for that. So you need to distinguish that this is
and
function.
Yeah, that's the part the engine understands. It's like functions that have this convention of calling by batches of rows. They have to basically have it's like effectively a table function invocation type of thing. It's a separate type of operator. It gets planned differently. It gets the engine reasons about differently. It has a different type of operator, but it doesn't inherently know about anything remote. That will be up to the connector to.
Makes sense.
I can actually also imagine using a batch calling convention for functions that aren't remote. Today, functions can actually have multiple calling conventions. So you could have a function where we're passing in the arguments as just simple Java primitives. We also have another calling convention where we pass in the block and the position in the block to get the data out. I can imagine that we might want to have a calling convention for a function like var binary length, where you want to, where we could have an optional version of that where it just takes the whole block, because the length of all the var binaries are just encoded as an int array in the underlying block, and you could just pull that out and share that through, which would be something that the optimizer would pick if that happened to be the leafmost expression, would be a good reason for doing that.
Yeah, I like the idea, especially another use case is, for example, when doing cast and involving timestamp or temporal times in general, you do lookups of various library objects to do the cast. So it could help. So in optimistic case, it gets inlined and eliminated by the JVM, but my assumption would be it doesn't happen in every situation. I didn't check actually, but having infrastructure and not betting on JVM is probably win in some cases.
Yeah. All right. If there are no more questions about this part, I'm going to move on and talk about polymorphic tables.
I have a question about previous part.
Yep.
SQL Defined Functions. I like the idea very much, and especially the thought about the different languages. For me, the role model would be what Postgres provides, because I'm not familiar with MySQL that well. However, I thought about storage, and I think we have a lesson to learn from our support for views. Mm-hmm. Currently, when someone wants to create a view in Presto, they need a Hive connector for that, even if they are not going to use the view for Hive tables, for example, for SQL connector. So I think it would make sense to have some built-in connector dedicated to storing. This is inherently Presto specific feature, right? Like Presto views are inherently Presto specific, and having a dedicated connector as a storage layer would make sense, independently from all the other connectors that one could be using for actually accessing data stores.
Yeah, so we thought about this a lot when we first ran into this problem space, and it's sort of like views, but there's actually a really big difference from views. So views, when you refer to a view, it's relative to your current catalog and schema that you're resolving all your tables against. So when you have a non fully qualified view, like it has to be in your local catalog and schema. Whereas functions have the advantage that there's a separate search path for functions. And so what that'll allow us to do is to write to have basically standalone catalogs that are only function catalogs that you can then mount all your functions in. So you'll be like,
That's true. So, so you could have a separate dedicated connector for views, but it wouldn't be as convenient as direct support for views in Hive connector, at least for Hive users. It would be more convenient for those doing federation. But with functions, the difference is, there is a difference, as you said, that you can do search path for functions. So it looks like location of function is a bit more flexible. So it makes if I have a dedicated connector for functions, it makes using it more convenient, because I can still use my use command to access tables in some catalog schema without qualifying them, and still can access my custom functions stored elsewhere thanks to setpath command. Right.
So the next idea we had was that what we'd like to do is to extend a bunch of the built-in systems that we already have. So expand the JDBC base connector so that you can do things like, hey, I want a MySQL catalog that doesn't have any tables, but supports functions, and then it writes the functions into MySQL, or it writes them into Postgres, or whatever you happen to have. We also think we might be able to store the SQL defined functions inside of the Hive Metastore for those using the Hive Metastore, if that's their only storage system. So basically the idea would be to look at each one of the storage systems and say, hey, can we legitimately create an encoding that's reasonable for this storage system? And then clearly have a bunch of configs to control turning it on.
Probably the minimal requirement for what you actually need is some key value storage.
Yeah. For views, we thought about also like the JDBC connectors could just have a Presto views table that stores all the view definitions. One complication is that views and tables are in the same namespace. So what do you do about conflict where somebody creates a Presto view that has the same name as a MySQL table, or in the opposite direction where they created the Presto view first and then they created a MySQL table name that shadows it later, which one wins?
Yeah.
But I mean, that's easy. We just need to pick what to do, but that's the complication.
Mm-hmm. Right.
Okay, so this last section here is, I feel like it's only really related to the previous subject because it has the word functions in the name. So
it's very related to the batch convention, though.
Yes, yeah. So the SQL language has had table functions for a really long time.
Yeah,
I think forever.
Yeah.
But in the latest spec, they added polymorphic table functions. So I'll try and explain this at a really high level, but definitely jump in with questions. So a table function is a function that produces a collection of rows, which we commonly call a table, but is really a multi-set of rows,
yeah,
I think in the spec.
If you look at the specification, it says that any table-like expression, like that could be a from clause, a join clause, a group by, etc. They're all called tables. And the type of a table is a multi-set of rows.
Yeah.
And multi-set is a type in SQL, row is a type in SQL. So that's how you think about them.
Yeah. So unnest is probably the most common one you see. And so you'll see that in a table where you'll say, hey, I want to select from this table and then do a cross join of the row against an array in that row that's been unpacked. So you end up duplicating all of the normal columns, and then you have your row elements going down.
Well, actually, the simplest way the simplest example for a nest, you can do select, start from a nest and pass an array. So that's a table function. A nest there behaves as a table function that takes an array as input and produces a collection of rows, a multi-set of rows, basically a table.
The problem is that in the spec up until 2016, table functions had a predefined static signature. So you'll sometimes see in databases, they'll have like a sequence table function where you can say select from sequence 1, 100, and that will return a table that has one column that's just a big int or something like that. So that's powerful, but it leaves out a bunch of really useful cases around something you'd want to do with a more dynamic structure to it. And we'll give some examples here. So the big difference with polymorphic table functions is that instead of just having this fixed signature, the query engine basically has a protocol where it's interacting with the function, and allows it to it allows the function to negotiate what its signature is going to look like based on the actual arguments that are being passed into the actual arguments that are being passed into the function. This spec, it's worth actually Googling for. There's a the spec committee produces a paper. They produce the full formal spec, which is very difficult to read, but for this one, they produced a paper that describes in much more human readable format that describes how you can use the polymorphic table functions. And it's unbelievably powerful. It's powerful enough that you could actually describe all the features in SQL, like joins and aggregations and things like that, through this one abstraction. So I'm just going to give some examples. So the first example here is, so this is doing select from table. So table is a keyword that most people aren't aware of. You can put inside a table can either be the name of a table or a SQL defined, a table generating function. So in this case, the first one is saying, I want to select from this function CSV reader, which is, in this case, just reading from some file. And it's describing the output shape of this file. So it's saying, hey, I have a CSV file. So this function I pulled both these out of that paper. So this function assumes that the CSV file has a header row that has the names of the columns. And basically what they're saying is, hey, wherever the column principal and interest are, those are going to be floats. And there's, if you see a column named due date, that's going to be a date. So the idea with this function in the spec example is that during planning, the engine would talk to this function and say, here are the arguments. So there's a file argument, it's this constant value. Here are some descriptions of, these are schema descriptions that are passed to it. And the function would actually go and look at that file, get the names of the columns, and then present back saying, okay, I actually have, 5 columns. I have, customer name, I have principal, interest, due date, and, comment or something like that. And it would give the actual types for those. So you can imagine this would be a really powerful way to do something like, oh, I have a function that can read from a Google sheet, and here's the URL to the Google sheet, and it just pulls the data. The next example is the example that gets most Hive, people familiar with Hive, excited. So in this example, this is saying, I want to select from a table. What this table is going to do is invoke some script. Which is very much like the, what's the syntax? Transform syntax. And this is really powerful because the next argument is I'm going to input, and then here's the input is a entire nested subquery. And in this case, they're actually giving the output names of the values and things like that. But you could, for example, go and interrogate the script and figure out what the outputs are going to be. So this is all I had about this. There's the spec is actually really huge. So there's a way to talk about how data is partitioned into the function and things like that. But I think these were the best examples that I think most people are excited about.
There are functions that can process for each row of input, one or more rows of output. There's others that can act as set functions. Like, for example, you can simulate an aggregation with that. There's functions that can take multiple tables as input, and then internally it can do an arbitrary or they can do whatever type of join they want. So you can simulate a join with that, or you may have some more complex algorithm that is not possible to represent in one of the join types in SQL.
Yeah. So we built a prototype of this a while back. We built something that could basically fetch files like a CSV reader from a URL. And we built a thing where we were using this to feed entire tables to remote thrift services and then getting a table answer back, which is similar to a remote function. So this is actually an interesting, what's actually happening here is interesting because we actually have gone through and we added things like the JMX connector. And it's possible that some of those connectors like JMX might actually fit better as a table generating function than having to try and map, you know, a JMX name into a table name or things like that. So there's places where we've gone through and done this with full catalogs that might be more powerful as functions.
Well, you could almost think of a table as a table generating function that takes no arguments, right?
Yeah, well, what's funny is I think of this this table syntax here, because you can be like table and then my table. I think of that as the table generating function that fetches data from that storage descriptor. Yeah. So. Anyone have any questions? You got querying metrics from something like Graphite. That might be a good. I'm not super familiar with Graphite, but if it's like the JMX stuff, like what we did for JMX was, it was interesting, but we had to like figure out how to map the table names in, and so you just end up with these like table names. They're like these really long strings. And actually, like in JMX, there's multiple ways to represent the same data because you can reorder the key value pairs and things like that. So it doesn't actually fit really well into a full catalog. So if Graphite has some sort of like lookup mechanism, that might actually be a really powerful way of pulling that stuff in. Also, like, I think of this as, okay, I just want to pull some data from somewhere like Graphite, right? And my answer today is, okay, I have to write an entire connector, which is a huge amount of work, when really, like, I could probably do it in like a couple hundred lines of just script. I fire up the client and pull the data out. So I think it'll be a lot easier to deal with things with this.
Yeah, this is huge, and especially on like one-off integrations with something, or some POC with integration with external systems. Did you think about the possibility to express polymorphic table function as a SQL-based function, or register dynamically?
Oh, yes. Yeah, they'll go through a similar resolution system to the stuff I showed earlier for scalars and aggregates, but it's much easier because they own the entire namespace of their name, whereas SQL functions, like, you have to do type matching, things like that. So it's
no overloading.
Yes,
correct. You can't. I mean, you can't. Because the parameters, so the shape of the output changes based on the input, so you can't have the type inference engine do that for you.
Oh, also, I didn't point out, if you look at these examples, notice that these use named arguments. The SQL spec actually supports named arguments for everything.
Yeah.
We just haven't implemented it.
Yes, on my list to do.
we support it for procedure calls only.
Oh, I didn't know that.
Yeah, we do. Yeah, but it's allowed for any function invocation.
Yeah, so someone asked about like Google Sheet, Office 365. I completely agree. The other thing is, you can use, like, I could see this as being a good way of pulling data out of those systems. You could also use this to push data in, like right to a Google Sheet or something like that. And then you'd have a function that just, I don't know, returns the number of rows written or something like that, and then pushes all the data into a sheet.
That would be harder because you have to deal with what happens if the query fails, you have a side effect, there's no...
Sure,
So,
sure. But then again, like, depends on the quality of service you want from your function. I was thinking about views that do list generation similar to Python comprehension syntax. It looks like these could do that. Thoughts?
I'm not sure I understand the question. Like if you're talking about like functions that generate like say sequence or something like that, actually this is could be a good fit for a function like that. Like it could be, and it could be parameterized on different things. Like you might want a sequence that produces doubles or sequence that produces integers and so on. But if that's not what you meant, like maybe you can elaborate that and we can talk about it.
Well, list comprehension lets you do like transforms or filtering, which we actually have today with Lambda functions for arrays.
Okay. Yeah, actually that's something that could be done as a table function. Actually, that's exactly what a projection does. It's a table function that takes a table as an input, applies a bunch of lambdas, and produces output. So we could even have a function like that could be invoked directly if we want to. So last question, can we share the paper? Yeah, I'll post a link to that PDF. It's available online. I'll post it on the channel after we're done.
Sequence generation is the type I was thinking about with multiple columns. Yeah. I was also like thinking that sequence generation might be a really nice, useful, where it's like you just have a function that's like sequence, and then you have a list of sequences, and you're just like, here are the types, here's the start value for them, and then it just knows how to iterate through them.
Yeah, which we kind of have today with, you can generate sequences of arrays, but you have unnested, and it's not nearly as nice.
So one thing I think we should think about is whether we can unify, or what can we do to unify the notion of, like we see pages, and we represent collections of rows as pages, but we represent arrays of rows as blocks. Yeah. So if we could unify that concept, and I actually been thinking about this in the background for a while, then we could, in theory, leverage all the functions that operate on arrays could be invoked as table functions, and maybe vice versa. So I think there's something we can, it's a kind of synergy there that we can take advantage of. But
so and a row-block and a page are very similar.
Yeah, exactly. Yeah, exactly. Row-block is exactly. Row-block is.
So for those who don't know, there's a page in Presto is like a top-level object, and it has a bunch of blocks inside of it. But there's one type of block called a row block, which inside of it contains a bunch of blocks. And it has, those blocks have one position for each position in the outer block. So they're like, it's square. And so a page is actually just a row block under the covers.
Yeah.
But we don't treat them that way.
Yeah, I know. So I think there are some opportunities there. If we could unify that, then like any function today that takes an array of rows could act as a table function, for instance, or produce an array of rows could act as a table function.
Yeah. One difference is in a row block you have nullability per cell, which you don't in the page.
Correct. Well, and a row block has to have at least one nested column, where a page doesn't have to have any nested columns. Yeah. But really the only reason a page exists separate from rows is that we had pages long before we had row types.
Yeah.
Like 2 years before. So.
Okay. Any other questions? We have only a couple minutes left.
No? All right.
Okay.
Presentation.
Yeah.
Please let us know if you have additional topics you want to cover. We got some feedback from the previous list, but if there's other things you want covered in detail like this, just let us know. We really do need this input to be able to come up with the next set of topics for you guys. And if you want to present a topic, please let us know.
So after we're done, I'm gonna create a channel in Slack for the functions topic. I'm gonna post the link there. So if anyone's interested, just join the channel. I'm also gonna post in the general channel to announce it. So we can, any additional questions people have about this topic or any of the topics related to functions, we can discuss there. All right. Thanks everyone for joining.